Oops, I pushed the button too early. All right, so we're going to look at dividing exponents. So when we say dividing, most of the time they're going to write it with a fraction bar, but because we're using Prodigy to practice, sometimes they'll actually have a division bar, so I'll show you that too. So with multiplying, we added the exponents. So dividing is the opposite of multiplying, so we're going to use the opposite of adding, which is subtracting. So if I have x to the a power over x to the b power, I get x to the a minus b. So that's what we're going to do. And
so it's the opposite?
Yes, it's the opposite. So instead of multiplying, we're dividing. So instead of adding the powers, we subtract the powers, which is kind of cool.
And it only works if they're the same number?
It only works if they're the same number, yes. So if you look at our examples, it has to have a base of 5 and 5 or 2 and 2. And I'll explain why that works here in a second. So I'll explain why we can subtract them. If we write this out in expanded form, 5 to the 6th would be 5 times 5 times 5 times 5 times 5 times 5. On the bottom, 5 to the 4th is 5 times 5 times 5 times 5. Well, we can cancel some of the 5s on the top with the 5s on the bottom. So I could cancel those, and those, and those, and those. And we're left with 5 times 5 on the top. So if we think about just the exponents, if we're using the rule, you're going to take 5 and you're going to subtract 6 minus 4 in the power and get 5 squared. This is why it comes out 5 squared, because there would be 2 5s left over in the numerator. And then my answer, if we're actually, we talked about the word evaluate. If they say to evaluate something, they want you to go all the way. That means we're actually going to take 5 times 5. And my answer would be 25. So this is the answer in exponential form that we're looking for. And this is the answer evaluated, where we actually do the math to figure it out with the repeated multiplication. But this is why you can subtract, because basically the ones in the top and the bottom can cancel. And there's going to be a little bit of a twist in the middle. We're going to start with the easy ones. So if I have 2 to the 4th over 2 to the 1st, literally I'm just going to do 4 minus 1. So 2 to the 4 minus 1 power, and 4 minus 1 is 3. So the exponential form would be 2 to the 3rd. So that's my answer for exponential form. And then for the answer evaluated, I actually have to take 2 times 2 times 2. So 2 times 2 is 4, and 4 times 2. So sometimes it helps to write it out. So 2 times 2 is 4, and then times 2 is 8. Sometimes people will look at this and they'll do 2 times 3, or they'll look at this and do 2 times 3 and get 6. It's not how it works, because you have to multiply the 2 by itself 3 times. So you really want to think about that. And you can check those with the calculator. It'll let you do 2 to the 3rd, and you can just check and see what that is. But I want you guys to try to do as much as you can by hand. All right, so if I take 2 minus 2, I have 2 minus 2, I'm going to get 3 to the 0 power. So remind me, when I have something to the 0 power, it's always 1. And we had a little activity we looked at the other day for why it's always 1. And it kind of has to do with the pattern as we look at positive exponents and negative exponents and what's in the middle. All right, so to do the second half of this, we have to review how to do integer subtraction. And it's funny because I just did integer subtraction with the 6th and 7th graders. When we did integer subtraction last year, we had a little thing called keep, change, change. We only use this if there's negatives in the problem. So we didn't need it up here because these were just regular 6 minus 4 and 4 minus 1. And but down here we're actually going to end up with some negatives sometimes. And so we're going to talk about how to do integer subtraction first. So we're about halfway through, and I'll get you the top half in a second. So when you're subtracting and you've got negatives in there, we do keep, change, change. So that means you keep the first number, so we keep the negative 3. You change subtraction to addition, and you change positive 2 to negative 2. So I have negative 3 plus negative 2. We learned all kinds of ways of adding integers last year. You could think of this as 3 worms and 2 worms being added together, which wouldn't cancel or kill each other. We talked about red chips and red chips. This would be 3 red chips and 2 red chips. But nothing would cancel. We just get more negatives, and so the answer would be -5. Okay? Now, there's no negatives on the next one. It just has 4 minus 8, but it's not a normal problem. 8 minus 4 would be easy, but 4 minus 8 is a little bit more challenging. If we rewrite it using keep, change, change, we would have 4, and then change subtraction to addition, and change 8 to -8. And we can think of it in terms of 4 of these negatives canceling out the 4 positives. And think of it as 4 spiders and 8 worms meeting on the battlefield. And remember that 1 spider and 1 worm cancel each other out. And so we'd be left with definitely worms. They're winning the battle. How many worms would be left standing?
4.
4. I know it's sort of a really violent way that we learned that, but it helps us understand, hey, the negatives are winning, and there would be 4 of them left over after we canceled stuff out. All right, so subtracting negatives is also interesting. Still keep, change, change. So you have 3, you change this to addition, and you change this to +2, and then it's just 3 plus 2, even though we started with subtraction. Because basically, subtraction is just addition of the opposite. That's why we do keep, change, change. We get 5. And then the last one, we have a -8. We'll keep that. Change this to addition. Change that to +4. So -8 plus 4. It's basically just like what we did over here. And we get -4. So hopefully that helps us remember how to do the negatives, or any problems that you cannot just subtract normally. You want to use keep, change, change to think about. So our formula says we're going to be subtracting powers. So if I have 5 squared over 5 to the 3rd, what I'm actually going to do over here is subtract 2 minus 3. So let's think about that. That would be, if I do keep, change, change, that'd be 2 plus -3. So what's that power going to come out as? -1. So that's my answer in exponential form, is 5 to the -1. And then what does that mean when we have a negative power?
If you fraction.
Make it into a fraction. So that means I'd have 1 over 5 to the 1st power. And when I flip it over, the negative goes away. It does not make it a negative number. I no longer have a negative power. I just have to do 5 to the 1st power. What happens?
5.
Which is just 5. So my answer is just 1/5. Now, I want to talk about why this works, just on this first one. So if I wrote these out the long way, 5 squared would be 5 times 5. And 5 cubed would be 5 times 5 times 5. So if we're canceling, we're left with a 5 in the denominator and nothing in the numerator. But you have to have something in the numerator. So okay, we can take anything times 1 and it doesn't hurt anything. And that's where we come up with 1/5. So this is why this also works with the negative powers, and why the rule works the way it does. Whoever worked all of this out was amazing, in my opinion, that we can just subtract the powers and that's what's going to happen. Okay, so if I have 3 to the -1st over 3 to the 2nd, if we're just using the rule, we're going to have 3 to the -1 minus 2. You subtract the powers. So since I've got negatives up there, I can't subtract that using normal, regular arithmetic. We're going to keep, change, change. So you keep the -1, change it to addition, change this to -2. So what's my power going to be if I add -1 and -2 together? So I'm going to have 3 to the -3rd. So that's my answer in exponential form. Okay, so then if I want to evaluate it, what would I do? 1 over 3 to the 3rd power, and then I have to think about what 3 times 3 times 3 is. So 3 times 3 is 9, and then 9 times another 3 is 27. And I should point out that sometimes they actually want this over here in exponential form. Sometimes they'll tell you they want exponential form with no negative powers. And so technically both of these are exponential form. This is using negatives, and this is using positives. And so you really have to pay attention to what they're asking you for if they want exponential form. If they say no negative powers or only positive powers, or that the powers have to be greater than 0, there's all these ways that they can ask it. This may be what they're looking for. Yes. All right, so let's look at the next one. When I have 2 and there's no power on it, what power do we put on it? 1. Good. People holding up one finger. So we can change that to 2 to the first. And actually, I'm going to write that as a separate step, just so when I photocopy this, it will be apparent what we did. So then the math that we're actually going to do is we're going to take 1, and we're going to subtract -3. So if I do keep, change, what is that going to look like? What do I do with these numbers? I'll start you out. You keep the 1. What else will I have?
It's a
+3.
+3.
Awesome. And so my exponential form on this would just be 2 to the 4th. And then over here I have to think about what that is. And I have a way of working out these that, so if it's 2 to the 4th, sometimes I'll do these in pairs. So that's 4, and that's 4, and then I'm like, oh, the answer is 16. Otherwise, you can do 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. Either way works. We have this cool rule called the commutative property. It says you can multiply in any order as long as it's all multiplication. But I kind of like pairing those up, especially if you get into bigger powers where you might have like 6 or 8 of them.
Same with addition.
Huh?
Same with addition.
Yep. Okay, so let's go down and look at this one. So I have powers on both of them, that's fine. But there's an awful lot of negatives. So I have to remember that I'm subtracting, and I have to remember to keep the negatives. So I'm going to have -2, I'm going to subtract, and then I have -4. And I want to make sure I can see those as separate symbols. So if I'm doing keep, change, I'm going to keep the -2, change that to plus, change that to positive. So what would the power end up being? 2. 5 squared. So that's my exponential form. And then I just have to do 5 times 5 for the answer, which is?
5.
Good job. So if we can remember integer stuff, we're okay.